Please enter your name to log in. Welcome, Michael. Garrett is currently in the room.
Hey, Che. So we're going to go through a current demonstration of the prototype. Where's Garrett at?
Yeah, hello.
Hey, Garrett. Okay, so all right, Garrett. So what we're looking at right now is the entire patient population over time, and we're looking at the risk. So the higher the value on the y-axis, the higher the risk, and these are all our different patient IDs. So to make this a little more relevant, Garrett, could you filter this down to just patient 5, please?
Sure. Right up.
Very nice. Okay, so this patient is interesting for us because their risk is declining fairly significantly. If we look at this initial data plot, we see that his risk is at 1.9, and if we go further down, we could see fairly significant drop at 1.0 at the end. But what's interesting here is the data between year 8 and 9, Garrett, is actually sporadically rising. So during a period where it had improved, it suddenly got worse. So I'm curious why. The first thing I want to do, though, Garrett, is run a prediction. And I want to know what Vera thinks is going to happen to this patient whose trajectory was getting better, but then suddenly got worse. So, Garrett, could you run a prediction for year, 12 for this patient?
Sure. I can. Coming up now. Should be. There it goes. There it goes.
Nice. Ooh. So it looks like it continues to rise. Interesting. Could you predict for year maybe 15?
I sure can.
And the way that he's doing this, everybody, if you're curious, is using this method in this hand menu. There's an option to predict. So, oh, good. So it looks like by year 15, this risk is sloping back downward. But that initial risk was starting to concern me. So good. Let's actually look at this patient in a little bit more detail, Garrett. And before we do, I'd like to know a little bit more about you. So I'm going to click on your avatar's name tag, and I'm going to move that a little to the left so I can see it here. Oh, you're a software engineer, huh?
Yes.
Okay. All right.
There I am.
So another function that Garrett's built in the system, besides the grabbing feature I just showed you, is a cool OK to close. So if I make the OK symbol, boom. Garrett, so what we're going to do now is look at this patient in a little bit more detail because he is an interesting case study. His risk started rising and then it dropped. So I'll just start with this first data point and wanted to learn more info. And this is a capability that Garrett's built, but again, use the hand menu here. And this, ladies and gentlemen, and Che, is that patient. So John Doe, we have his picture, we have his ID, we have all of his data variables. We see he's age 53, no high cholesterol, obviously a male. And the general idea behind this user interface is a system overview of the patient's body. The idea is that if the patient's system is bad and is experiencing some kind of medical event, then it would be red or yellow. And if it was okay, it would be green. For the case of this demo, we've preloaded the cardiovascular system since the focus is on aortic stenosis. And I can see a general overview of the organs in that system eventually, and we'll be able to see which pieces potentially are being impacted. But I want to see this in 3D. So I just click it, and I'll move him down a little. Actually move him out to the side. So this is a representation of the patient's body, and the idea is that this is the user interface to see the patient's data. For a provider looking through a system of numbers and EHR can be cumbersome, but actually seeing the data in front of him, where maybe if he wants to look at that aorta, he can just, I don't know, press it. Let's start with the heart. Oh, there it is. So in that scenario, he'd be able to load all the patient's heart data in these two panels and interact with it in much the same way that we do in the other panel. Now, we also have the aorta active in there, so if I want to cut away a little, boom, and we'll get some more data on the aorta. This concept is very preliminary. We only have 2 of the organs with active interfaces, but the idea is that we should be able to house any data related to that specific organ in these 2 panels in a way that can be modular and modified based on the doctor's interests. So again, if I want to close this, real easy, just make the OK symbol. Boom, she's gone. And let's close that. Now, before we move on, I want to focus a little bit more on the hand gestures. So, Garrett, you there?
Yes.
So, would you like me to show you the rotation feature or the scale feature first?
How about rotation?
You got it. So, what we're going to show you is a simple hand interface that, if you make an L, rotates the data that you're looking at. And if you make a left-handed L, it does the opposite. Now, this is actually taking the position of my eyes into consideration, and it's only rotating the object that I look at. So if there was another data point or an object, it would only rotate based on what my eyes were fixated on. Not head, but actual eyes. The second is scale. So if we want to make this thing small, we just pinch. If we want to make it bigger, we just do that. So I'll do it again. The lighting is a little bit poor in this environment. It causes the hand tracking to be a little less than perfect, but let's show you again. So scale, let's go even bigger. All the way, let's fill up the whole room. We can really dive inside of our data. Now this is only one axis. So earlier I showed you the full data set. For the sake of time, I'm not going to go back to it, but imagine being able to see many layers here and many dimensions, and then being able to easily dive in. See more. Now, Garrett, what am I missing here? Where are you? Oh, there you are. What am I missing?
Behind you. Well, yeah, you did it to the data object here, but it also can be done to the windows that you interact with. I know you showed them the
Yeah.
grabbing windows with your fist and
Right.
moving them around.
Let me show them the hand menu. So the general idea is we want this.
Hand menu,
Yeah, we
yes.
want this system to be as fast as possible to use, but there is a little bit of a learning curve. But once you picked it up, it's so simple. You just open your hand, and there's your menus. And let's say I wanted to, I don't know, shuffle the axes of this data. All right, Garrett. Now,
So
what I
here we
didn't
have
point
the-
out is Garrett and I are located about, I don't know, 80 miles away right now. And we can hear and see and talk to each other. But more importantly, we can see where each other are looking, and we can point things out. So, Garrett, what side of the graph, what values are you looking at?
Well, I am on the time side
Yep.
of the graph. Currently.
Great. And I'm on the ID side, right?
You are correct.
Right. And that's synchronized even when we do things like, I don't know, rotate the graph or scale the graph. So, but what I wanted to show real quick is the ability to filter this down. So we're looking at all the patients in the current patient population. All of them had aortic stenosis, but we want to look at just males, and we want to also focus on males that are in cluster 1, which is an especially interesting cluster for us, and I can talk about why, and maybe Che can talk a little bit more about why in a second. But once we apply that filter, and it's going to take a second for the server to get the new data and update it, and now we're actually only seeing males that fall into cluster 1, and the interesting characteristic about cluster 1 is that their risks are all improving, Garrett. So the cluster 1 is essentially the best cluster of the patient population, and just like the other data, we can real easily click on that and dive a little deeper into the data and find out this is John Doe. Apparently we're using online photos where our commander-in-chief's picture was used. Can assure you this is not his actual data, but if it were, we'd be able to do things like we did earlier with the cardiovascular, but we'll do the nervous system this time. And and that's it. We could also do the skeletal. And the idea is generally, eventually we're going to have 3D data for most of the areas of interest for the body, and we'll be able to actually see those scans. But they're also a user interface to interact with the data. So we see things like data that's relevant to the patient's cardiovascular system, for example, being accessible through that interface, like I showed you earlier with the heart, where we'd get our heart data here, and if the heart were in bad condition, we would see some kind of alert, whether it's a signal or a color or something. So there is the ability to also filter by color, and that last thing, that last step that I took filtered it and entirely removed all the non-matching patients, but we can do that and just apply a specific color. So for example, why don't we look at just patient, we know patient 4 is in that pool, and we're going to apply as color, boom, and that's patient 4. So if we were talking to a patient, or we're looking at my own data and I wanted to get the context behind that and see how I compare to the rest of the group, this would be an excellent way to point out exactly where I am relative to that. So this patient's in pretty good condition, normal, but overall compared to the rest, he's excellent because he is in cluster 1. So going through the user interface too extensively would take a lot of time, but there are a few things that I'd like to show. Primarily a different view of the patient pool. What we were looking at there is largely data driven, and some people would prefer to actually see the patient's faces, their bodies, understand who they are, and that's what we're about to see, if it'll ever load. Nice. So what we're seeing here is a representation of a different way to visualize the patients in your pool, and here we have their pictures, but we would want to be able to know which patients are in good and bad condition, and we'd want to be able to filter through things like go to my males or just go to my females. And these are the females. So within that population, let's say that we were especially interested in this one, and it turns out she's had a aortic valve replacement, and I click on her data. Then I could easily go into the same data set and and then be able to interact with which organs and data I'm interested in. So with that, Garrett, is there any other features within the hand interface that I'm missing?
Within the hand interface, no, the capability to close and open new files, and you can also manipulate objects through buttons on the hand interface if you don't want to use the gestures for some reason.
Right, right. So that's this button here, which allows you to move, rotate, and scale, depending on what you've clicked. The lighting is a little off in this space, so the hand tracking is a little lower fidelity than usual, Garrett, but overall I think it showed the concept. Is there anything else that I'm missing?
I don't believe so.
Very good, sir. Well, Che, it's been an honor. Happy to show you this current iteration of the prototype. I'm looking forward to getting it on your device. Garrett, you want to close with anything?
I hope you enjoyed it.
Thanks, Garrett. Thanks, Che. Thanks, everyone. See you later.